The idea now is to try to understand why there is so much debate about global warming and climate change. It's of course easy to say that climate has always changed. It's not a big deal. But as I said, we only appeared on the scene very recently. The changes before, we don't know if we would be able to live through those if there are big changes. That's one thing. The other is to try to understand whether global warming is happening, and if it is happening, whether we are causing it, and then whether we should spend money and change our lifestyles to reduce the global warming rates or global warming itself, right? So climate change cannot be stopped. Natural changes will continue to happen. It is this push in the warming direction that we are producing that we must worry about. Why is there so much controversy? So let's revisit this point again. I made this earlier in one of the podcasts. So here is the Charles Keeling curve that we have seen, which has become now very iconic symbol of global warming and human activities. The current levels of CO2 concentration in the atmosphere, parts per million by volume, are over 415 by now. Each year it increases by 2 to 3 ppm. Measured at Mauna Loa, but not at many other stations. So the full record ending in May 2019 it shows 415.39 ppm. CO2 is well mixed, and it has a long residence time, and it is inert. So if you measure it at one place, you know very well the concentration in the whole hemisphere. There is a slight hemispheric difference. We can also measure the CO2 in the other hemisphere, and we know very well how much CO2 there is in the atmosphere across the globe. It's very accurate, very precise measurement. Whereas when we look at the warming, here is the same thing, the CO2 curve now shown by removing the year-to-year variations. We may not have said explicitly why there are these sawtooth structure in the CO2 record. I think you already know it, probably heard it somewhere already. Right? This is the so-called breathing of the atmosphere. As sun comes up in spring in a particular hemisphere, spring blooms happen, vegetation begins to photosynthesize on large scale, so CO2 is drawn down from the atmosphere. And when the summer is over and fall begins and the leaves begin to fall, especially at higher latitudes, even in the tropics many trees are so-called deciduous, photosynthesis becomes much weaker and CO2 begins to rebuild in the atmosphere. So there is this year-to-year cycle, and you can remove it to see clearly. The trend is fairly obvious here anyways. There are also ways to see how global CO2 is affected by El Nino and so on using this same data. You will have to take the time rate of change and so on, which we won't get into. So this smooth curve here is CO2 shown on the right axis here, which you can see again close to 415, just above 415. And the temperatures are shown as a deviation from the base period. So it goes from 1880 to 2019, so fairly recent when I'm recording this podcast in October of 2020. You can see that we started at the Industrial Revolution, end of the Little Ice Age, with temperatures that were below the present baseline period, which goes from 1961 to 1990. So temperatures were cooler compared to the present baseline. And then it started to cross and become warm around the middle of Second World War. There are lots of data issues, how the global mean is created, how the data coverage is not uniform, and all those things. But scientifically, this is very robust. So there were again these warmings and coolings, but since about the mid-1970s, temperature has continued to increase just like CO2, but still there are ups and downs. Each year is not necessarily warmer than the year before, but we will see that each decade has been warmer than the decade before. But yet, when you look at this curve, some vested interests who want to argue against global warming keep saying, look at the CO2 increase and look at the temperature change. They don't correspond to each other. So how do we know CO2 is causing the warming? There were questions about whether the CO2 increase is because of what we are doing or whether because the ice age ended and this is just a natural increase, which does happen as we will see a little bit later, and so on. But we will see that using carbon isotopes and oxygen measurements, we can actually show that the accumulating CO2 in the atmosphere is in fact coming from fossil fuel burning. Okay, there are ways to do that, we'll see. And we also know that because the sun moves across the equator seasonally and sunrise, sunset happen, there is this seasonal and diurnal forcing with the internal feedbacks which create internal variability or natural variability. You already know few of the internal variabilities or natural variabilities. Those are things like the Indian monsoon and El Nino, right? These are not forced by human beings, they are natural. So when El Nino happens, we saw that the warm water comes out of the deeper ocean to the surface and it makes the atmosphere warmer. So during an El Nino of 1 year long, there is actually a mini global warming happening because the ocean which has accumulated the energy is releasing it. But here we are talking about a continued increase of global mean temperatures, right? So natural variability will not go away. Global warming will continue to modulate the natural variability and create a trend on top of the natural variability. Okay? So we'll keep making these points, but also in addition to the ocean being able to keep the energy and hide it away for a long time, remember we said ocean is deep, has high heat capacity, and there are regions where heat can sink, as we know. Ocean takes up 90% of the energy that is being produced by the excess CO2, etc. Energy is also going into increasing water vapor in the atmosphere by a little bit, melting glaciers, that takes a lot of energy, right? We will see that Arctic ice is disappearing, Greenland glaciers are melting, some parts of Antarctica are melting, and so on. So energy can be distributed within the system. So here we are starting at the Industrial Revolution is started earlier than this, but this is where the best temperature records start. So you can see these ups and downs. You can, if you're careful, you can find each of your El Nino and La Nina in this as well. And you can see, and even the volcanic eruptions which cool the temperatures temporarily and so on. And the total warming has been about 1 degree centigrade over this period. And there is some evidence that the warming had slowed down just a little after 1998 till about 2014 or 2015 or so. Okay, there is a lot of debate about that, but it turned out that ocean was hiding more heat during this time. So global warming didn't stop. It's just that more energy went into the ocean. So the atmospheric warming looked like it was slowing down. Total energy trapped was still increasing. This is tricky, we have to remember. But these things can be used by people to confuse laypersons saying, look, there is no relation between what we are doing and global warming. This is why there is so much controversy. Okay, so here it is again comparing carbon dioxide and temperature rise. And I lost the figure here, but I will show it a little bit later, which shows that each decade has been warmer than the previous decade. So even though year by year temperatures go up and down, each decade is getting warmer compared to the previous decade. That's another nail in the coffin against the argument that global warming is not happening. Okay, that argument should be put down already, but there are lots of businesses, energy companies, and so on, and people who do not want to change the lifestyle, our energy-intensive lifestyle, who keep arguing that.